Hello class, hope you're doing well today. We're now entering into our last section of the course, and that is on the topic of evolution. So let's get started. When we think about evolution, realize that this is a theory in the realm of biology, and one of the greatest quotes about the theory of evolution was stated by Theodosius Dobzhansky. And he stated that nothing in biology makes sense except in the light of evolution. So evolution is really that foundational theory behind all of biology. In fact, without the idea of evolution or the theory of evolution, all of biology is just a random collection of facts. Nothing really ties it together except the theory of evolution. And in fact, the theory of evolution is so powerful that it even helps us to explain some of the oddities that we see in biology. So for example, all of us have muscles attached to our ears, but very few of us can actually wiggle our ears. So why do we have muscles attached to our ears? Well, the theory of evolution explains this, in that our ancestors had these muscles attached to our ears so they could actually move their ears, not unlike how maybe a cat would move its ears so it could better detect sounds and directions. Now, as our ears moved down the sides of our heads to where they are now, muscles were no longer necessary to move those ears, but there wasn't really a negative, a harmful case of having those muscles, so they stuck around. So this is how evolution can explain what we see in the natural world. So when we think about what this idea of evolution is, realize that it is a biological theory, and as a theory, it is actually one of the most broadly tested theories that we have, in that it's been tested independently by multiple other scientific disciplines. So the theory of evolution has been independently tested by the realm of geology, by looking at the fossil record. It's been independently tested by physics, which has made use of radiological data to date those fossils, to see how old they are. It has been independently tested by the realms of chemistry and biochemistry, which take a look at the molecular aspects, which all of these data fully support the theory of evolution. And to this date, we really haven't found any data to reject the theory of evolution. So as a theory, it simply proposes that all living organisms are modified descendants of more ancient organisms. And that's what the theory of evolution is stating. Now, I do want to caution you, one of the things that the theory of evolution does not address is how life got started. When we talk about how life got started, that is a separate scientific area. The theory of that is the theory of abiogenesis. So evolution says once you have life, that the environment will select for those individuals who have traits that are better suited to that environment so that they can survive and reproduce. Those individuals that are not well suited to that environment are less likely to survive and then are less likely to pass their traits on to the next generation. And it's important when we think about the theory of evolution, we often think of Charles Darwin. He actually used the term descent with modification. He didn't actually even originally use the term evolution. So when we think about this on another level, the theory of evolution is really about the change in gene frequencies over time. So from one generation to the next, how does a population change? Or how does the genetic makeup of a population change? And that's really ultimately what evolution is about. So those traits, genes, various traits that are better suited to a given environment will become more common in a given population. Those traits that are less suitable become less common. And that's our idea of evolution. One last thing to talk about evolution for us to keep in mind is that it occurs at a population level. This occurs upon groups of organisms. Groups of organisms have the capacity to evolve. Individuals cannot evolve. You cannot change your genetics to become better suited to your environment. So that is something to keep in mind. We're going to start off here by taking a look at some of the history of the development of the idea of evolution. And as we start out this, we're actually going to go fairly back, ways back in time to an individual named Al-Jahiz. Al-Jahiz was started off early 800s, so in the 9th century, and he was very much interested in the natural world. His parents were from Ethiopia. He was actually born in Basra, which is part of Iraq now. And at that time, the Middle East was really the central area where scientific progress was being made on the planet. So they were really the scientific leaders in the world. And he was put forth to study the diversity of life that was present. And so he was taking a look at various animals. And he actually wrote this idea. These are his, basically the idea is that animals engage in a struggle for existence and for resources to avoid being eaten and to breed. So this seems kind of basic, doesn't it? But this is a fundamental concept in evolution. There's this struggle for existence. You've got to go out and get resources. And you've got to avoid being eaten and then to breed, to pass your traits on to the next generation. But where he really got it was the second part of this. Environmental factors influence organisms to develop new characteristics to ensure survival, thus transforming them into new species. Animals that survive to breed can pass on their successful characteristics to their offspring. He hit that idea of evolution right there. So if we really want to think about who is the forefather of the idea of not only evolution, but ultimately he had the idea of natural selection here. Al-Jahiz was very much a forefather in that research. Now, I do want to change our time scale here to something a little more modern, although, yeah, we'll use that term loosely. We're going to think about Western thought here. So typically when we look at the development of our scientific knowledge, Western research is where we base most of that. And we're going to go back to about the 1700s. And we want to think about how did people in Europe primarily, so what we're looking at here, how did they view how organisms or the history of life and biology? So first off, their view was that basically an interpretation, or literal interpretation of the Bible, and that the earth was about 7,000 to 10,000 years old. And based off of the story in Genesis in the Bible, they believed that organisms were created in their present form. This was referred to as fixity of their species. And in fact, humans were indeed specially created. And in fact, since we were specially created in the likeness of God, as is stated in the Bible, it was commonly believed that we were not even animals. We were apart from the rest of the natural world in that sense. So as we move forward, keep this in mind as part of your background of where Western science was coming from. And fortunately, they did not hold on to Al-Jahiz's, or not aware of his findings. So we kind of had to go back to the starting point again to discover about evolution. So we're going to start off with a guy you've probably heard about, Carolus Linnaeus. The dates there are not going to be critical for us. Those are just for a frame of reference, so I'm not going to test you on those dates at all. But what he did is he came up with a classification method for living things. So you're probably somewhat familiar with this. So you have a large level of classification at, oops, sorry about that. Let me go back here. There we go. We've got the kingdom level. So here we've got the animal kingdom. And then you have groups, smaller, more specific groups after that. So here we've got a group of the animals that are called chordates. These are basically going to be all animals that have backbones. And then you've got smaller groups that are even more specific. You've got the mammals. So these are groups of the class level, the mammals. Then we've got the order level, which are the carnivora. So a group of carnivorous animals. Then we move down to the Canidae. So the dogs fall into this, and we start to narrow that down, the genus Canis, till we get to a single species, Canis lupus, which is the wolf. So this was actually a starting point for our understanding of evolution in Western thought. And what this was important for is it helped us to see how organisms are related to one another. So other scientists, other philosophers even at the time, could start to take a look and say, hey, you know, these organisms here, they all share a bunch of characteristics. Maybe they have a common ancestry. So likewise, you know, we look at things like the horse, the donkey, the zebra, okay? All of those, they're very similar to one another. Maybe they come from some common ancestor. Now, just one thing before we move on, this kingdom, phylum, class, order, taxonomic levels, you will not be tested on those. So, you know, you can take a deep breath there and don't stress about that thing.